All right, hey AP Chemistry. Now I'm going to do question 10B. I already made a video on A, and I've made a video on 8 and 9. If you knew or followed how to do question number 9, question 10B is the exact same style of question. So I'm going to rewrite the equation. 2NOCl gas in equilibrium with 2NO gas plus Cl2 gas. And the Kc expression was already given, like the value was 4.2 times 10 to the minus eighth. And it says when 55.5 molar of NaOCl is initially placed in a reaction vessel and allowed to reach the equilibrium in this reaction, what is the equilibrium concentration of each substance? So if I have a question like this, I am going to be doing an ICE table, right? So for any questions where I give you an initial reaction, and initial amount of reactants, and it reaches equilibrium with a Kc, I'll do an ICE table. So 55.5 molar. Initially, I'll have no products. And I'll just set up my ICE table as such. I should have given you more room. Okay. Sorry that this is not neat. That's okay. And so, according to this balanced chemical equation, my change will be minus 2x plus 2x plus x. 55.5 minus 2x, 2x, and x. If I want to write the Kc expression, it'll be brackets NO squared, Cl2, just raised to the first because there's only one of them, over NOCl squared. I'm going to plug in all of these values into this expression. These are my equilibrium concentrations. They're expressions because they're in values of x. I'm going to plug in these values of x's into the equilibrium expression with the value of the equilibrium expression already given to me in the problem, which is 4.2 times 10 to the minus eighth. So I'm going to have 4.2 times 10 to the minus eighth equals NO2 squared. So 2x squared. Cl2 is just going to be x over NOCl squared, 55.5 minus 2x. And that whole thing is squared because it's raised to the second, or because it has a coefficient of 2. Now, since Kc is very small, again, values of Kc that are small are 10 to the minus fifth or smaller, or 10 to the minus fourth or smaller. Since Kc is small, I could assume this x in the denominator is 0. Since Kc is less than 1, x will be approximately 0 in this denominator. And so now this expression becomes, I'm going to rewrite it, 4.2 times 10 to the minus eighth equals, I'll combine these right now. 2x squared times x is going to be 4x cubed over 55 squared. The minus 2x is gone now. It's going to be 55.5 squared. I'm going to do that already on the calculator. 55.5 squared is going to be a huge number. 3080.25. 3080.25. And that's already with it squared. Otherwise, you'd write 55.5 squared, and then you get 3080.25. Now, your job is to solve for x. That value of x is what I plug in here. So I'm going to, if I want to solve for x, 3080.25 times that number. So this times 4.2 times 10 raised to the minus eighth. This is just solving for x, so this is just algebra. So I'm going to do 30.825 times 4.2 times 10 to the minus eighth. And I get 1.29 times 10 to the minus fourth is equal to 4x cubed. Okay. And then if I want to solve for x here, I'll divide by 4 and then take the cubic root of it. So I'll divide by 4, and then eventually I'll take the cubic root of both sides. And this is going to give me I'm kind of summarizing this all in one. How did I know to divide by 4? This is multiplied by 4. I want to get x by itself, so I divide by 4. And then I want to get x by itself again, so I got to take the cubic root of both sides. If I do this math correctly, I'm going to do it on the calculator. I got this number, right? I'm going to show you with the number that I got before. I'm going to divide by 4. And I think there's already a number that says cubic root. So 4 second answer, right? So cubic root of my answer here, I get x equals 0.03186. 0.03186 molar. That value of x is always going to be a concentration, 0.03186 molar. And so now I plug these values in to x. So Cl2 concentration is just going to be equal to x, which is 0.03186 molar. NO is just going to be 2x. NO is equal to 2x, which I'll just multiply this number by 2 times 2. I get 0.06372. 0.06372 molar. And then finally, NaCl is going to be 55.5 minus 2x. I'm going to do the math on the side. 55.5 minus 2x is 0.06372. And I get 55.44 approximately. 55.44 molar. So those are my equilibrium concentrations, which is what the question was asking for. Okay? So again, I know this is all squished down here, and I'm sorry. In the future, we'll have a lot more space. We do an ICE table. You solve for the value of x using algebra. You don't have to use the quadratic equation because we're assuming this value is small. Plugging and chugging, solving for x. Once you get your x, you plug that value of x right into the E portion of the equilibrium table. And this E gives me my concentrations when I multiply or do whatever I need to. Cl2 was automatically equal to x, so there we go. NO, I had to do 2x, and again, the 2 came from the stoichiometric coefficient, so 2 times that. And then NaCl, I had to take 55.5 minus 2x. Just like in a BCA table, but now we're at equilibrium. Alrighty, so hopefully this video was helpful. It was another example of how to use an ICE table. The numbers were not as crazy as question 9, but still the same process. If you have any other questions or concerns on how to do problems like this, please let me know.